Hey, it's Kevin Lawton with the New Warehouse Podcast, bringing you a new episode today. And on today's episode, I am going to be joined by Dr. Mor Peretz, and he is the CEO at CaPow. And CaPow, we have talked about a little bit on the podcast before with our friends at JLC Robotics, but we're going to dive deeper into their technology and the solutions they're bringing when it comes to charging and power delivery within the warehouse space. And very interested to hear about this technology, how it kind of came about, and really the benefits that it has for our industry. So, Moore, thank you very much for joining me today, and welcome to the show. How are you?
Hey, Kevin. Thank you very much. Thanks for having me.
Yeah, absolutely. Very happy to get you on here. Very happy to dive deeper into Kapow, which I love the name of. It's just fun to say
Thank you.
to begin with. So, why don't you kind of tell us just a brief overview for people maybe that didn't hear that previous episode or are interested to know what is Kapow and kind of where did the idea for this company come from?
All right. So, CaPow, the first of all, maybe a word about the name. It's a word game for
Sure.
capacitive power. And
Mm.
what
Oh,
we're
okay.
what we're after is addressing the operational efficiency problems in automation in warehouses. Either it's manufacturing floor, logistics, fulfillment, and all the sorts, uh, and primarily caused by and the energy problem. So the idea is uh, part of a journey that I had for many years. In my background, I'm a professor of electronics,
Mm.
doing hardware development for many years. Uh, in a few years ago, already quite a few years ago, I had two of my students graduating PhD, working on um, very close topics to this, and we had this idea of um, taking an alternative way of wireless energy. And we decided to spin off this idea out of school, and basically that's what we did. And this seed of an idea grew as we understood more and more of the features that the technology allows us to do. Basically, the core technology of CaPow allows you to have quite flexible freedom of positioning in terms of wireless energy transfer. Uh, and it is so flexible uh, in a way that it is even supports motion. So we're able to uh, still have the energy flowing between the pair of transmitter and receiver while maintaining motion on the robots or whatever the receiving end is. Um, so this evolved and grew, and as we understood more and more the problems and issues that are related to automation, we started to focusing on that more and more. Of course, as every startup, we explored many uh, applications. Maybe we can talk about that later on. But what are the
Sure.
possibilities to touch with this type of technology in general? But as we understood more and more the issues and what they stem from in general for in the automation world and warehouses in more particularly, we decided to focus our efforts there, and yeah, here we are.
All right, great, and I do love the name as I mentioned there, and I love that you're able to take that kind of name convention and bring that together. It certainly catches your attention, and I think we're happy to have you in the warehouse space. Happy you decided to focus in on our industry, and I think to run our industry, obviously we're moving material. We have a lot of moving pieces that are going on, and we need power to be able to do that, right? And you mentioned in there kind of some of this wireless charging technology, but I see a lot of what you're focused on is called perpetual power, right? So tell us a little bit about what is perpetual power and how does that maybe different? How is that maybe different from some other solutions out there that are focused on like what's wireless charging?
Yes, absolutely. So, in the tagline "Perpetual Power," what we're trying to convey is the fact that we're supporting power for vehicles, robots, machines
Hmm.
while they're on the go. So we differentiate charging being a stationary action as opposed to a dynamic charging or a perpetual power, as we named it, being able to support uh, delivery of power or energy while in motion. Now, taking it one step further, once you are able to support motion or energy delivery in motion, you are able to downspec the size of the battery that the robot would hold, or even eliminate it altogether. And this introduces a whole new range of solutions and applications for warehouses that cannot run uh, batteries for many reasons, from temperature reasons, from safety reasons, uh, from sustainability. As we grow along, lithium ion is not the nicest element to work with, or the nicest material to work with.
Hmm.
We see evidence of that every day in the news. Not only in EVs, but in warehouses too. We have, in the past, several, warehouses that actually been totaled as a result of lithium malfunction. But more than that, in general, lithium and lithium ion is a limited resource and a problematic resource to handle. Especially when you need to
Hmm.
maintain it, recycle it, handle its end of life. Um, so by supporting this power in motion, or perpetual power as we named it, we're able to provide that as well.
Mm. Interesting. Yeah. Yeah, yeah, and I think it's a very interesting approach because, like you mentioned, it takes away that need to be stationary, right? To get that charge, whether and there's you do wireless charging, but that still means that hey, you need to be in a certain spot, and you're just not plugging in, right? It's not like you're getting power as you go, but with the perpetual power, as that machine, that piece of equipment, whether it's robot or something else, is moving, it's still collecting that power, right? So I mean, in that sense, tell us, I guess, from your perspective, like why is that important for our industry, the warehousing industry? Like, why is that important? How does that make us more efficient? What
Yeah,
really are the benefits there?
yeah, absolutely. So uh, when you look at the warehouse operation today, modern warehouse of today, you have robots all around. Um,
Mm,
from small robots to larger machines, forklifts, you name it. You name it. The range is endless, and there are a variety of companies, focusing on various applications, and similar to tires in a vehicle. Nobody gave a
mm,
thought, what would be the exact, the best charger, for this solution. Now, as this technology keep becoming more and more mature, more and more end customers, from the smallest, grocery stores that run, automated deliveries, to the biggest fulfillment centers, they share a common pain point, which is the
mm,
downtime that is associated with charging. Uh,
right.
the work to charge ratio of today, even, some of them are three to one, and it ranges,
Mm,
let's say, up to 8 to 1. But still, this is a significant amount of time that a particular robot sits down and it's not working. And there are, some can claim that there are other solutions. You can do a battery swap, At the end of the day, there is a significant downtime that is associated with charging. Now,
mm,
what we're after is finding the best way to have the robots work 100% of the fleet would work 100% of the time without compromise, not
mm,
close to it, not approaching it, like really taking the energy issue out of the equation. Uh,
mm,
getting the robots to be 100% efficient in terms of their tasks that they're set to do without extending the fleet size. Many of the solutions just compensate in adding more robots. In many applications, this is not the best solution. First, of course, the entry fee increases just to compensate for the charging, which is absurd.
mm.
I don't imagine a person get another phone just to have another battery, right? Uh,
Yeah.
I wouldn't, or getting another car just to have another fuel tank, right?
Yeah.
So why we're doing it in the automation world? Because it's a new field, and
Mm,
within this new field that is very demanding, that has to be absolutely reliable and maintain operation of 24/7 in the automation world we're running. That's very aggressive, and even if it's not 24/7, the shifts are consistent, 8 hours, 10 hours, 12 hours straight. And um, and the energy and the energy equation is just don't cut it. And as we would grow
yeah.
along, the tasks would be even more demanding on the robots. So our approach is to provide a solution that would give you this freedom of uh, disengaging from a stationary put, and of course from
Mm,
all mechanical constraints, and at the same time would be seamless from a deployment perspective. So it wouldn't be complex. So it wouldn't cause headaches to the operation guys, right? You
mm.
wouldn't need to
Yeah.
excavate the floor. You wouldn't need to integrate um, complex utility tasks. It's a straightforward. Within half a day, you're in and out, and you get
Really.
100% of the fleet 100% of the time.
Hmm. Very interesting, and I love that you tied it there and said you wouldn't buy another car just to have another fuel tank, right? Which I think makes so much sense, and I think it really puts the problem you're solving there into perspective. So, I mean, would you say not only is it increasing the uptime, but I think from a cost perspective, then too, I would think that instead of having 15 robots running around, I mean, maybe you would have 10 instead or something
Right.
like that. So, I mean, are you able to say that, like, essentially having this type of power delivery, you can reduce the overall fleet size that you need?
Yeah, so absolutely. So from numbers perspective, we ran this year over 100 discovery talks with customers, and
Yeah.
all across the board, all suffer from the downtime problem,
Mm,
and we can quantify the benefit of CaPow anywhere from 20% to 35%, and at some cases even more. It all depends on the cluster size. How many robots are in a particular cluster working together. How many robots are here to compensate. What is the work to charge ratio? How long is the route? And actually, for that, it's not hand waving. We developed a tool.
mhm,
They got, for guys who wants to play with it, they can go on our website. There is a portion of this tool available to play with. They can put in their information and see a layout suggestion. How complex would it be to deploy, and how quick and easy it would be to get uh, fleet optimization. Now, more than that, this is just the first entry point. Now,
mm,
since we manage the energy better than depleting the battery and recharging it, depleting the battery and recharging it, we also extend the existing battery life cycle considerably. So that's another
mm,
benefit. And on top of that, you can add additional features such as uh, the actual real estate area that is today allocated for charging stations can be now
mhm.
repurposed uh,
All right.
for additional storage, for additional utilization, and so on. But I don't want to deter all the robotic manufacturers and the OEMs saying now we're going to cut down their business in 30%. I would say I would look at it the opposite direction.
Yeah.
There are already several cases that we're engaged with, that they were hesitant to introduce automation altogether because of the entry point price tag. And
Mm,
once we offered them another view and showing that we're able to reduce their capex entry price uh, in 15, 20, 20, 35% at
mhm.
time,
Yeah.
um, the OEMs got further business. So they actually gained more
Right.
business with us integrated than just selling more robots into a single event.
Mm. Yeah, I think that's such an interesting point and way to look at it. I mean, I think that makes a lot of sense, right? Because you, like you said, I mean, you have somebody maybe that's on the fence and the price is just a little bit out of reach, and then all of a sudden you cut that cost down by, like you said, 15, maybe up to 30%. That's a big difference when you're looking at some of these
Yeah.
solutions and what they go for. So really interesting how
Maybe even
you're
one
able
more
to
thing
create those efficiency. Sure.
I now remember now more than that. Let's say going on to a retrofit, and let's say you save instead of 15 robots now it only needs 10. So there
Mhm.
always work in warehouses. So these five
Yeah.
robots are immediately repurposed for another job and making it more
Mm,
efficient and getting the warehouse even more efficient. In overall, we see already testimonials from our customers that we're saving in their bottom line in percentages, and we're
mm.
talking millions of dollars in savings
Yeah.
in the bottom line.
Yeah, yeah, I think that's great, definitely, and so I'm curious, how does if we want to do, and you just mentioned the word retrofit in there, but if I'm a warehouse and I'm looking at your solution, I mean, what does it look like, I guess, and what does it mean to kind of put this solution in place? How does an implementation look? Do I have to change my floor? Do I have to change anything about my infrastructure? How does that all kind of take place, and how does that work?
All right, so we worked really hard to try to get to the definition of a true plug and play,
Okay.
meaning we are fully agnostic to the platform, the type of robot, the type of surface, or even the orientation of how it is positioned. Basically, our antennas, or what we like to call stickers, they're very
Mm,
thin, and they can be virtually with any shape or form. They can be long and narrow, they can be wide and short, they can be bent, they can be wrapped around, they can be laid
mm,
on concrete, on wood, on plastic. We can even accommodate metals, and we're not sensitive to metals, and we're not heating up metal objects that are in our field.
mm,
So it is very safe from a debris perspective, or heating up, some metallic residue that may exist on the floor or wherever. We can be accommodated on the racks, so for ASRS applications as well. Um, Really, the versatility and the customization that comes free with the integration is endless. And basically, it's a pair. We set up uh, the what we call the base antenna, the transmitter,
mm,
and each robot gets his receiving sticker,
mm,
um, and of course the electronics that goes with it. The transmitting box connects to power uh,
mhm,
in some way, either to the utility or other source that is available on with the particular deployment, and that is basically it. There are no changes needed on the production floor. There is no particular clearance that is needed to be done. In terms of safety, it is all compatible with the stringent
Mm.
classification of FCC, UL, so it is very safe. They can be, worked around even people.
Yeah.
So, and the installation itself is super easy. Let's say for a cluster of several robots, let's say a few dozens, it's less than half a shift worth,
Oh wow.
and is fully integrated.
Oh wow. Interesting. So it's, I mean, it sounds pretty like a pretty simple setup and something that you really don't have to make much change to make happen. I'm curious for, if we look at warehouses, obviously, many are very very large, and there may be like a large area that an AMR, for example, is covering, moving pallets around or something like that. What is your recommendation for, like, I mean, how do you assess, like, in what areas or how much space should you be putting your solution in? Is it everywhere, or is it like, okay, let's put it in a specific aisle or a
Mhm.
specific area of the warehouse? How does that work?
Yeah. So going back to our floor planning tool, basically
Sure.
the inputs to the algorithm are the layout of the facility, the robot's heat map, or
Mm,
the average routes that they take, and of course the electrical characteristics of the robot. And what the tool is basically after is searching for the best routes to create a positive energy equation. Of course, let's say if there are specific constraints, let's say there are no sticker zones here,
mm,
the customer saying, there is a heavy traffic, and with like vehicles that scrape off the floor, and he's worried.
mm,
Although our stickers are our antennas are extremely durable, both from weight perspective and from rigidity. But let's say from for some reason they decide not to place an antenna, so it goes also into the algorithm. And the algorithm outputs are route suggestion and the strategic places that we suggest to place the antennas, and basically uh, what we uh, uh, are committed to or guarantee is that we maintain a positive energy equation on the battery or on the energy source throughout the operation for the worst case scenario. So let's say for the minimum interaction with the CaPow pods or the CaPow areas, to the longest routes available. And basically,
mm,
what we're after is to trying to find the highest traffic points in the warehouse, or the algorithm searches for the highest traffic points, and 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 places the transmitting devices in that areas. Or let's say
mm,
for example, highways or specific aisles that the robots pass through, or for example, on a dispatch station, or a put away, or there are several uh, you know places that most of the traffic converges onto. So
right.
the algorithm looks for the highest traffic points, and of course, if needed, we're placing additional ways en route. Uh, what also I didn't mention, that the length of the antenna uh, is also manageable. So we can go anywhere from
Mm.
3 feet to 30 feet. So let's say,
Oh, okay.
so it can support also, like while driving, like while in motion, the robots really don't need to stop to get energy.
Mm, mm.
Uh, yeah.
Interesting. Interesting. Yeah. Yeah. And I love that you guys are assessing that too, and trying to figure out, what's the best positioning, and where to put that. Like you said, where there's high traffic. So it's going to constantly be hitting that, and getting that power, which I think goes, even further to making sure that you have that 100% uptime, which I think is so critical. Definitely. So let's touch really quickly on, because you mentioned in there in kind of the beginning of our conversation around lithium ion, and it's not the best thing to work with from like an environmental perspective and things like that. So how does the CaPow solution, I mean, how does that help with sustainability and the green approach, for warehouses that are thinking about that and are concerned about that?
Yeah, so we recently did a research work investigating the impact benefit on CaPow, and we tried to be very focused on direct impact. So what is called in the industry scope 1 and scope 2 effects, and leave scope 3 to later on investigation, because this is very specific to the type of operation you're running. What
Right.
partners you're running with, who's gonna take how you're gonna ship the vehicles, the robots. So there are many uh, variables in place. So we took a very specific scope 1 and scope 2 from the perspective of how many robots we save, and and what is the impact on the lithium ion batteries that we're able to provide, from a
Mm,
positive perspective. And we end up that in 2027 we would save 50 megatons of CO2 equivalent, and
mm, wow.
based on our current sales and sales forecast, and growing with this trend, taking all the uh, bench measurement bench criteria, by 2050 we will be way beyond 1 gigaton.
Mm. Wow, interesting. Yeah, yeah. I think it's so important to note that too as well, especially as that becomes, not only what people are concerned about, but also as those regulations and things start to roll out in
Oh,
certain areas
so I have to
of the
mention
world.
a point in that. So one of
Sure.
our design partners we've been working with, they were going back and forth. They really wanted to disengage from a battery altogether. They wanted a true what we call
Mm.
a powered solution. Uh,
Oh, okay. I like that.
yeah. So so they went back and forth, and it's a brand new design. What is called in the industry a greenfield installation.
Mm,
Uh,
right.
and at the end of the day, the design team, they said, we're still hesitant, and we want to have a battery after all. We will have CaPow, but we still want to have a battery for backup.
Mm,
And they got a pushback from their operations and logistics division, saying we don't have the proper warehouses to store lithium ion
right.
materials. We would need to add humidity control, temperature control, sprinklers, safety protocols that are considerably different from maintaining, nuts and bolts, or
Yeah.
storing nuts and bolts. And they got back to us and saying, okay, we're taking this extra leap of faith and eliminating the battery altogether. And this worked great. This works awesome. The robot doesn't even think of going to the charger because it doesn't have a battery.
Oh wow, interesting. And then it's just continuously getting power because
Yes.
of the CaPow
So in
solution,
that
right?
in that case, what we had is we have our own design of a power pack based off a super cap.
Mm,
It's just what we call an energy buffer that takes the robot from one CaPow pod to another,
mm,
and basically,
uh,
instead of compensating for hours, we're just compensating now for seconds. So for in a range of,
Interesting.
let's say, 10, 30 seconds, 90 seconds or whatever, it gets juiced up and ready to go again.
Mm. Very interesting. Very interesting. Very cool solution, definitely. And I think it's really interesting to look at it from all these different perspectives. And it's interesting because I've been talking a lot lately and looking and thinking about these almost invisible problems, you could say, in a warehouse where it doesn't necessarily jump right out to you that this like small process could have such a big impact. But when you look at charging and power delivery, right? I mean, I think people just take it for granted that hey, this thing is going to go charge, or we're going to
Right.
plug this thing in at the end of the shift, or opportunity charge it in some way. You don't think about all of the potential opportunities there are for efficiency gains and productivity gains overall, from being able to have a better solution around that. So it's really interesting what you guys have put together and are putting out into the market to be able to gain some of those efficiencies and cut overall costs down, as we talked about from a fleet perspective, and the number of robots or equipment that you need to have overall, I think is huge. So very interesting to learn about this solution. I'm curious, as you're looking in the market, and obviously you're seeing what types of robotic solutions are out there. I mean, what are your thoughts for kind of the future of robotic solutions for this year and maybe going into next year as well?
Yeah, absolutely. But I have to touch the your previous comment in one more
Sure.
thing that I really appreciate. I really like this story. I hope you like it too. So we had uh, we had once we're starting evolving the technology and really find it really cool to power up robots in motion. We started to investigate the market. This was 3 4 years ago, and we
Mm.
were coming to places of new deployments, just deployed brand new. The robots are still shiny and sparkling, no wear and tear on
Yeah.
them. The tires are still slick, and they make this squeaky noise on the floor when they're running. Everything brand new.
Yeah.
And we were asking, do you have this issue of downtime? No, everybody said, we everything is amazing. The automation is amazing. It runs really smooth. The same guys, 2 years after, they called us and said,
Yeah.
listen, we cannot handle this downtime issue anymore. We suffer from it so bad. We cannot
Yeah.
we cannot take it anymore. Just come and fix it. Like
Mm.
and it's was still amazing how much it's not only time, it's the experience of uh,
Mm.
of really working with it on a day-to-day basis, getting the understanding that this downtime is not an earned energy problem. It's an operation problem. It really
Right.
is. It comes really at the cost of throughput and the bottom line, and the
Yeah.
production loss. And it's really like that. The guys that are complaining about it are not the robots guys, are the operations guys, are the guys that handle the ones that count out how many boxes are out on the truck. And
Mm.
this was really fascinating for us to see and experience firsthand. Going
Mm.
to your original question
Sure.
on our roadmap and how we vision the advancements in robotics. So I would say, first of all, a general comment, that from all of what we see, not only from stats, and dry numbers, but we really see the operation in warehouses physically, that
Mm.
the growth is amazing. Like, this is a super
Yeah.
super super growing field and market. And every day there is an introduction of an additional layer of automation that really makes the warehouse a very cool place to be in. It's
Yeah.
not only getting this box out uh, of this. Going 50 years ago, my dad used to be an inventory manager of a big facility, and I remember him
Oh, okay.
running, having guys running, across the. These days are long gone. uh, and
Yeah.
and 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 the automation now is skyrocketing the efficiency for that, and the type of machines and solutions that exist today already and are being introduced every day are really mind blowing. From a very very small robots to very large machines, uh,
Mm,
and as we see our benefit and where we play along, is that today our main focus is what we call mobile robots, AMRs, and AGVs, and
mhm,
we're planning to address slightly larger machines within the warehouses within a year time, going on more on
okay,
forklifts and larger vehicles. And
mhm,
at the end of the day, going into the e-mobility applications that are associated with logistics, manufacturing, and fulfillment, such as the fleet vehicle services like e-vehicles. I don't know if you noticed, but all the main delivery companies today, especially in New York, Jersey area, already are
yeah,
shrunk down to a very
oh, yeah,
much smaller one and becoming electric. And basically,
mm,
every vehicle that has every electric vehicle that has a defined route or a semi-defined route would
mm.
considerably benefit from CaPow. So,
Yeah, yeah, absolutely. I think it would be very interesting to see how does that expand outside of the warehouse too, as you mentioned there, from a transportation perspective too. I mean, it would be incredible to have some type of like charging lane on the highway or something like that. I think would be very
I
cool to
think
see.
we're
So
slightly taking it slightly ahead, but I really do see it in
yeah,
the upcoming time to that
mm,
we would be able to impact fleet vehicles like delivery
mm,
vehicles. So let's say within a city or within a suburb, or
mm,
or this type of cases, I see them, or even in the dispatch areas of this type of vehicles. Definitely. Also, not only those, but let's say tuggers of all sorts. It can be in harbors, whether it's seaport or an airport, or this type
mm,
of basically fully autonomous machines.
yeah,
They can significantly benefit from having Kapow.
mm,
And every now and then we get a request from uh, close customers to try to power up other applications. So this year we also played a little bit with drones for applications of
mm,
landing.
yeah,
There, the main problem with drones is the accuracy of landing.
yeah,
Or there is actually a very very cool company that having drones for inventory in warehouses.
yes,
The
yeah,
idea there was that the idea that we played with is that they use a very small drones. So basically, they need to go back and forth to charge all the time. So the idea
mhm,
is to place Kapow on the racks and basically having the drones hover just around them. They would never land.
yeah,
Yeah. So
yeah.
uh,
Interesting. Yeah. Yeah. I think there's a lot of different applications that I could see this being utilized for. And it's very interesting to hear your perspectives and talk all about kind of the technology here and how it's addressing a lot of issues within the warehouse and helping from that power perspective as well in a environmentally friendly way too. So very interesting what you have here more and very interesting to learn about CaPow. If people are interested in learning more about CaPow, what's the best way to do that?
yeah. So first of all, visit our website, kapow.energy. Uh, and we're also being showing in Modex um,
Okay.
in upcoming March, and our booth number is A 12 uh, 320. So one two
Yes.
three two zero. Yeah, and we're gonna have a booth with a full demo in Modex. By the way, there for people who saw CaPow in the past. Now we're going to have we got a bigger booth, so we have more space. So we're going to have a very long antenna, and we're going to have several brands of robots going back and
Mm,
forth on the driving on the antenna and getting juiced up as they go.
mm.
So hopefully it will be a cool demo. Uh,
Yeah.
it's running here, uh, and I have to say that maybe a small teaser, for guys who follow up our website and LinkedIn. Of course, we're also at LinkedIn at CaPow. Uh,
Mm.
and we're gonna open up soon a 24/7 stream of robots going back and forth in a warehouse mock-up that we did,
Oh,
that you can see them running and charging and different positioning, and
yeah.
getting all sorts of scenarios, weird scenarios, and seeing robots that being powered in motion, being played over the pods, and being basically 24 hours powered.
Oh wow, interesting. Yeah, we'll definitely be looking forward to that, and I'll definitely be looking forward to seeing that demo over at Modex. So, More, thank you very much for joining me on the show today and telling us all about the CaPow technology. And I think we're all a little more capowered now, as you would say. I will definitely put all that information at thenewwarehouse.com as well, so people can easily find it. So, More, thank you once again for your time on the show today.
And thank you, Kevin, again for having me. I had a blast, and I have to say that your website is amazing, and keep up the amazing work that you do. And warehouse are indeed very sexy.
Thank you. Thank you.